At 8:47 on the morning of April 14th, 1959, Port Director Jean Drapeau stood on Pier 9 in Montreal's Old Port, watching the first fully containerized cargo ship ever to dock at a Canadian Atlantic port, the SS Gateway City. Being guided to berth by tugboats navigating the St. Lawrence River's spring ice flows. 43 years old, 6 years managing port operations. He was witnessing the arrival of a technology that would either transform Montreal into North America's dominant inland Atlantic port or prove that the St. Lawrence River was too remote, too icebound, and too far from ocean shipping routes to compete with Halifax, New York, or Boston. The numbers made conventional port engineers nervous. Montreal sat 1,600 kilometers inland from the Atlantic Ocean. The St. Lawrence froze solid every winter, requiring icebreaker support for vessels to reach the port between December and April. The river's channels limited vessel size. Ships drawing more than 11 meters couldn't navigate upstream. But Montreal offered something competing ports didn't: direct rail connections to Chicago, Detroit, and the entire U.S. Midwest. A container arriving at Montreal could reach Chicago in 36 hours by rail. The same container arriving at New York needed 48 hours. Montreal saved 2 days, a critical advantage in time-sensitive freight. Gateway City carried 226 containers, the standardized 20-foot and 40-foot steel boxes that would revolutionize global shipping. Each container could be lifted from ship to railcar by crane in minutes, eliminating the days of manual cargo handling that made conventional shipping expensive and slow. Drapeau had convinced shipping lines to test Montreal despite the ice, despite the distance, despite skepticism from companies that thought containers would never replace break-bulk cargo handling. Gateway City docked successfully. Cranes offloaded containers onto waiting railcars. The containers departed for Chicago that afternoon. Montreal's container era had begun. The problem started in the 1950s when Montreal's traditional role as Canada's largest port was threatened by Halifax and St. John, ice-free Atlantic ports with direct ocean access. Montreal froze every winter, forcing shipping to reroute through the maritime provinces for 4 months annually. The city's port infrastructure, designed for break-bulk cargo in the 1800s, was outdated and inefficient. Montreal needed a competitive advantage that geography couldn't provide. The St. Lawrence Seaway, completed in 1959, created that advantage by allowing ocean-going vessels to reach Montreal directly from the Atlantic. Ships no longer needed to offload cargo to smaller vessels for river transport. But the seaway alone wasn't enough. Montreal needed containerization. Chief Port Engineer Marcel Savard, 51 years old in 1960, veteran of port operations across eastern Canada, understood that containers would eliminate Montreal's traditional disadvantage. Break-bulk cargo required manual loading and unloading, work that took days and employed thousands of longshoremen. Containers required cranes and rail connections. Speed replaced labor. Savard designed Montreal's first container terminal at Bickerdike Pier, a facility with cranes capable of lifting 30-ton containers and rail tracks that connected directly to CN and CP networks. The terminal opened in 1968 with capacity for 100,000 containers annually. The transformation was immediate. Shipping lines that had avoided Montreal because of ice and distance discovered that container throughput compensated for seasonal closures. A ship could be unloaded in Montreal in 18 hours, work that required 4 days in conventional ports. If you want to see how Montreal transformed from an icebound river port into Canada's largest Atlantic container gateway through technology that made geography irrelevant, please hit that like button. It helps us share more forgotten stories like this. And please subscribe if you haven't already. Back to Montreal. The containerization revolution required infrastructure that Montreal's 19th-century port couldn't provide. Cranes that could lift 30 tons needed foundations extending to bedrock. Rail tracks needed direct connections to CN and CP main lines. Container yards needed space to stack thousands of containers awaiting rail transport. Chief Construction Engineer Robert Fontaine, 48 years old in 1970, a specialist in marine infrastructure, supervised expansion of the container facilities through the 1970s and 1980s. The port built additional berths at Racine Terminal and Bickerdike, installed modern gantry cranes, and expanded rail connections. The ice problem remained. Montreal's port closed to deep draft vessels from mid-December to mid-April, when ice thickness exceeded 1 meter. Shipping lines diverted containers to Halifax during winter months, reducing Montreal's annual throughput. The solution was icebreakers. The Canadian Coast Guard stationed heavy icebreakers at Montreal to maintain shipping channels throughout winter. By 1985, Montreal operated year-round with icebreaker escort, the only major inland port to achieve winter operations. Container volume grew steadily. Montreal handled 200,000 TEUs in 1980. By 1990, volume exceeded 500,000 TEUs. By 2000, Montreal was handling over 1 million TEUs annually, more than any other Canadian Atlantic port. The port's geographic advantage became increasingly valuable as global supply chains optimized for speed. Montreal's rail connections reached Chicago in 36 hours, Detroit in 30 hours, and Toronto in 12 hours. Containers arriving at New York or Boston required 48 to 60 hours to reach the same destinations. The two-day advantage attracted shipping lines serving European routes. Northern European ports, Rotterdam, Hamburg, Antwerp, were 2 days closer to Montreal than to New York. A container departing Rotterdam arrived at Montreal 48 hours before reaching New York, then saved another 12 hours on rail transit to Chicago. Montreal became the preferred port for European imports destined for the U.S. Midwest. Automotive parts from Germany, pharmaceuticals from Switzerland, and consumer goods from Italy arrived at Montreal and departed by rail to American factories and distribution centers. The port expanded again in the 2000s. Contrecoeur Terminal, a new facility 40 kilometers downstream, added capacity for 1.15 million TEUs. The terminal opened in 2024 with automated cranes and direct rail connections, bringing Montreal's total container capacity to 2.85 million TEUs. Today, the Port of Montreal handles over 40 million metric tons of cargo annually across facilities on the St. Lawrence River. While container throughput exceeds 1.7 million TEUs, approximately 3.4 million individual containers moving through the port each year. The port operates year-round with icebreaker support, serving as the eastern terminus of both CN and CP rail networks. Direct rail service reaches Chicago, Detroit, Toronto, and the entire U.S. Midwest. Over 60% of containers arriving at Montreal are destined for American markets. The port handles critical imports, including refined petroleum products, consumer goods, and food products for Quebec and Eastern Ontario. Approximately 40% of Quebec's consumer goods arrive through Montreal's terminals, and Quebec's economy depends on the port operating normally. A prolonged closure, whether from St. Lawrence Seaway failure, labor strike shutting down terminal operations, or cyber attack disrupting automated crane systems, would immediately create supply chain disruptions across Quebec and the U.S. Midwest. Retailers would exhaust inventory within 2 weeks. Automotive plants would shut down as parts inventories depleted. Pharmaceutical supplies would face shortages. Quebec's refineries depend on petroleum product imports through Montreal. Closure would create fuel shortages within days. The economic impact would exceed $400 million per week. Manufacturing plants in Ontario and Quebec would reduce operations. U.S. companies dependent on Montreal's shorter transit times would reroute through New York or Halifax, adding cost and delay. The 2020 port strike demonstrated this vulnerability. When longshoremen struck for 19 days, container operations stopped completely. Shipping lines diverted vessels to Halifax and New York. Supply chains collapsed. The federal government imposed back-to-work legislation after economic losses exceeded $600 million. Unlike other Canadian ports with alternate routing, Montreal handles specific cargo flows that can't easily shift elsewhere. European imports destined for the U.S. The Midwest depend on Montreal's geographic advantage. Halifax can't absorb Montreal's volume. New York adds 2 days transit time. The system operates efficiently when functioning normally. It has no redundancy when failures occur. Jean Drapeau continued serving Montreal until 1986, transforming the port through containerization and securing year-round operations despite ice. He died in 1999 at age 83. The modern port owes its existence to his determination that geography wouldn't limit Montreal's future. Marcel Savard retired from the Montreal Port Authority in 1985 after designing the container infrastructure that made year-round operations possible. He died in 2003, age 94. The terminals he engineered handled triple the volume he originally planned. Robert Fontaine continued working on port expansion until his retirement in 1995. He died in 2018, age 96. And the rail connections he built remain the foundation of Montreal's competitive advantage. The Port of Montreal operates 24 hours per day, 365 days per year. Icebreakers maintain shipping channels through winter. Automated cranes offload containers at rates exceeding 35 moves per hour. Rail dispatchers coordinate trains departing for Chicago, Detroit, and Toronto every 6 hours. And somewhere on the St. Lawrence River, a container ship is being guided through the channel by tugboats, carrying European imports that will reach American factories 2 days faster than vessels arriving at competing ports, proving that Jean Drapeau was right. Technology and infrastructure can overcome geography. The system continues. Quebec and the U.S. Midwest depend on it continuing. If this story moved you the way it moved us, do me a favor, hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about infrastructure that connects continents to markets, real people, real engineering, real economic stakes. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You're not just a viewer. You're part of keeping these memories alive. Now, tell us your location. Tell us if you've worked in shipping, ports, or logistics. Just let us know you're here. Thank you for watching, and thank you for making sure Jean Drapeau, Marcel Savard, and the engineers who built Montreal's port don't disappear into silence.